Okay, hello everyone. Welcome to this tutorial. We are going to go through a chemistry paper which was written 2022, question 4. So the question reads, a sample of 0.03 gram of small pieces of magnesium was added to 20 cubic centimeter of 0.10 mole per cubic decimeter of hydrochloric acid. The two reacted according to the equation below. The equation is here: magnesium plus 2 hydrochloric acid giving us magnesium chloride and hydrogen gas. So question A reads, write the weight equation for the above reaction. Okay, so before we go to question A, where we are required to write the weight equation for the reaction above, the first thing when given such a question, because this is stereochemistry or more concept, the first thing which should trigger your mind is you have to make sure your equation is balanced. So let us check if our equation is balanced. Okay, when I say the equation is balanced, we are just trying to compare the number of individual atoms from the left and the right hand side of our equation. So I'll say left side in comparison with the right side. Okay, so let us start with each individual atom. So we'll start with magnesium from the left hand side. How many atoms do we have? One. We have one magnesium that side. Then to the right hand side, again here you can see we have only one magnesium. So magnesium, one to the left hand side and one to the right hand side. This means magnesium is okay, it is balanced. Next, chlorine. So chlorine, you can see that there's a 2 in front here, so we have two atoms of chlorine. So we have two atoms of chlorine from the left hand side, and from the right hand side again you can see that there's two chlorine atoms here, so we also have two chlorine, so it is also balanced, there's no problem. Next, hydrogen. So hydrogen, there's also a 2 in front of it. This means we have two atoms of hydrogen from the left hand side, so we have two atoms of hydrogen on the left hand side. Then on the right hand side you have a subscript of a 2 just after H, so this also means we have two atoms of hydrogen. So on the right hand side we also have two atoms for hydrogen. So we can see that our equation is balanced because the number of individual atoms from the left and the right hand side of our equation, they are equal to each other. Magnesium 1 1, chlorine 2 2, hydrogen 2 2. So by so doing you can now go on with answering. So the first question says write the weight equation for the above equation. Write the weight equation from the above reaction. So what we've been given here is a chemical equation. We just have to interpret it in two words. So in two words we just say magnesium, just using your eyes, what you are able to see there, it's magnesium reacting with hydrochloric acid to form magnesium chloride and hydrogen gas. That's what the examiners wanted you to give them. Then in the next question, what is the chemical test for hydrogen gas? What is the chemical test of hydrogen gas? They want you to tell them how can you test, if it is in the lab or wherever, to say the gas you are dealing with is hydrogen. Okay, so the identity test for hydrogen gas is that it put off a burning splint with a pop sound. So wherever you have your hydrogen gas in a beaker, so if you bring a burning splint near that beaker, you are going to experience a situation where the burning splint will go off and there will be a sound like, yeah. So that's all about the identity test for hydrogen gas. We move on to B, which says calculate the mass of magnesium which was in excess. Calculate the mass of magnesium which was in excess. So before we start answering, you have to go back to our statement and analyze our data. So from our statement, we've been given 0.03 gram of magnesium, then 20 cubic centimeter of hydrochloric acid, and also 0.10 concentration of hydrochloric acid. So let us analyze our data. We have magnesium 0.03 gram. Then for hydrochloric acid, we've been given two things, which is its volume, which is 20 cubic centimeter, and its concentration, which is 0.10 moles per cubic decimeter. So okay, I will advise everybody, you can compare the volume and the concentration of hydrochloric acid. You can see that on your concentration, the decimeter part, the cubic decimeter part, if you look at your volume, it is in cubic centimeters. So just there, they are not correlating in terms of unit. So you have to change your volume to be in cubic decimeter. Those are the standard units for volume. So to change from cubic centimeter to cubic decimeter, you have to divide your centimeters, the cubic centimeters, by 1,000. So if we take our 20 cubic centimeters over 1,000, so the answer is 0.02. So this is the volume of our hydrochloric acid in standard units. So this is the volume we'll be using in our calculation instead of the cubic centimeters, because they are not standard. We move. Okay. So with what we've been given, we use what we have to get what we don't have. So since for hydrochloric acid we have the volume and the concentration, we can use the two to give us the number of moles for hydrochloric acid using the relationship which says concentration is equal to number of moles upon volume. So we can just make volume the subject, sorry, I mean moles the subject. So we have moles is equal to concentration multiplied by volume. So from our data given, our concentration is 0.10 multiplied by our volume is 0.02. Okay, so you can pinch on your calculator, you punch. So the concentration, the number of moles I mean of hydrochloric acid is 0.002. So these are the moles of our hydrochloric acid. Okay, then now, since the question is talking about the mass of magnesium, so let us first of all also find the number of moles for magnesium which were used in the reaction based on what we've been given. So the reaction itself, the chemical equation, will help us to come up with the molar ratio, where we compare the moles of magnesium which reacted to chlorine. So you can look at magnesium and hydrochloric acid here. You are comparing them. So what we just compare here are the coefficient of each. So magnesium has got a coefficient of 1 and chlorine is 2. So we are just comparing these coefficients, which is 1 to 2. So this simply indicates that they are reacting in the ratio of 1 to 2. In the ratio of 1 to 2. So this means that one magnesium is able to react with the two hydrochloric acid compounds. So that's their molecular ratio. But from our calculation or from the data given, we've also known the exactly, because that chemical equation is just giving us the expected molar ratio, but the exact moles which we've been, according to the data which we've been given, is that we have 0.002 moles of hydrochloric acid. So using the specific ratio given, we can also calculate for the moles of magnesium which were involved actually in the reaction we are dealing with. So we say if one piece of magnesium is able to react with two pieces of hydrochloric acid, then X number of magnesium will react with 0.002 of hydrochloric acid. Okay, so we have this. Okay, so use our calculator again. Okay, so we have 0.001. So these are the moles of magnesium which reacted with the 0.002 moles of hydrochloric acid. So these are the exact moles which were involved in the chemical reaction of ours. So these molar ratios which we compared, which is 1 to 2, were the specific ratios which we expect our magnesium and hydrochloric acid to react at. But the exact moles which were involved is that 0.001 of magnesium was able to react with 0.002 of hydrochloric acid. So by so doing, you earn yourself a mark, although we are not yet done, because the actual question wants us to calculate the mass of magnesium which was in excess. So, and from our data, we've been given that during the start of the chemical reaction, we had 0.03 gram of magnesium, and the question wants us to calculate the mass which was in excess. So let us first of all know the actual mass which reacted, because we know the mass we started with, and the question wants us the mass which was in excess. So from the data we have, we can calculate for the mass which was involved in our equation using the relationship which say number of moles is equal to mass upon molecular mass. So the number of moles for magnesium is the one we are from calculating, which is 0.001. Then the mass is the one which we are looking for. Then the molecular mass from the periodic table of magnesium is 12. So therefore, our mass is going to be 12 multiplied by 0.001. Okay, so our mass which actually reacted with hydrochloric acid is 0.012 gram. So this was the mass which reacted. But initially we started with 0.03, then out of that 0.03 only 0.012 reacted, and the question wants us to know, or rather to calculate for the excess. So let us just find the difference between the mass we started with and the actual mass which took part in the chemical reaction. So therefore we're going to say the mass magnesium in excess is going to be magnesium original, which was the original mass, minus magnesium, the mass which reacted. So the original mass we started with was 0.03 gram. Then out of it, only 0.012 which actually reacted. So the one which was in excess will be 0.018 gram. So this was the mass which was in excess. So if this was being done in a lab starting with 0.03 gram, you would find that in that reaction chamber, this amount of gram of magnesium will be found in that beaker where the reaction was taking place from. Thank you very much. So this was what I had for you. Thank you very much.